Hello. Hopefully that should be fairly okay on the audio levels. Please let me know if they're not. And let's begin. There! I found the wrong buttons. There we go. Excellent. Right, I'm going to assume that you all can see that. Just to show there's nothing in my tree. We're all clean. So I haven't made any changes since the last time that we were looking at this. And where we left off, if you remember, was that we've failed to solve having found a hidden pair. And the reason that that was that there was a triple that we weren't spotting. I've made sure that we've still got the puzzle here in Sudoku Maker. And if we step this, then it's this naked triple that we're interested in. Naked triple in row 5, columns 1, 2, and 3. Removed 5, 6, and 9 from row 5, column 4, 6, and 7. So it's this 5, 6, 9 triple which we're failing to find. And the reason that we're failing to find it is because it's not 3 cells that all contain 5, 6, 9. It's 3 cells that between them contain 5, 6, 9. So the approach that we took to doing naked tuples isn't working. So we need to rethink that. So let's go and find that code. Techniques and naked tuples. So you see, we wrote this to do here. So let's just think first of all about what the process is that we came up with before. So we have for every region, we get all the cells in the region. Then what we do is we iterate all of the cells. We find the choices for that, and then we say if it's not solved, we insert that particular combination of symbols into a map. And so what that means is that we've ended up with one entry with 6, 9 as the symbol set, one entry with 5, 6, 9 as the symbol set, and one entry with 5, 9 as the symbol set. This is obviously not good enough. What we need to do instead is we need to be thinking about combinations of cells in the region. Whether it's the box or the row or whichever region we're talking about. Here we're talking about the row, but we can work this out whichever kind of region it is. So my thought here is to throw away pretty much all of this code. I mean, including all of that really, really painful code that we wrote about eliminations. In part because I think we might write an elimination helper, but in general because I just want to start from scratch and see what we can do to do this better. So what I think we need to be thinking about is combinations of cells. And by combinations here, I mean the old mathematical NCR combination thing. Not permutations, but combinations. And so I think it's about time that we break the unwritten rule that I didn't tell anyone I was working with, which was that I was trying not to use external dependencies until I absolutely have to. And the external dependency I want to bring in is called itertools. So let's very briefly get the documentation up for itertools. And the reason that I want to use this is because the trait that it gives us, which is called itertools, has a combinations. And what that does is it takes an iterator and you tell it what size combination you want, and it gives you back an iterator over vectors of items in that iterator. So in this example, it says, okay, we got 1 to 5. We want combinations that contain 3 items, and it's giving you, 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 5. And that's it. Because there are only 4 ways to choose 3 items from 5. And I think this is basically what we need to do. So what we are going to end up doing is we're going to end up looking for the unsolved cells as far as the symbol set that we're interested in is concerned. And we're going to look for the combinations that are for the size of tuple that we're caring about. So we're caring about pairs and we're caring about triples and so on. The code that we had previously only did pairs, until, well, sorry, in the hiddens only did pairs. But with a bit of luck, we can end up with roughly the same code doing both naked and hidden, although there might be some tweaks for hidden, using this functionality. So we're going to start by doing cargo add, and the package that we need to add it to is Kaji rules, and the thing that we're going to add is itertools. So that's added itertools to our dependencies for Kaji rules. And this enables us to use that functionality here. So let's go use itertools, itertools. So that gets us that functionality. So step one, as with every time that we've done these logical steps, we're going to go for each region. So, for region in state.regions. What occurs to me is the first thing that we want to do is we want to find all of the unsolved cells and save them, just like before. So what we're going to do is we're going to go, unsolved cells is region state dot region dot to cells filter. Given a cell, we want that cell only if it is not already solved. So we want not state dot choices at cell for digits solved. And we are going to collect that into a vector just so that we've got it to hand. So let's see what happens. So filter, no method named filter on that because that's already returning a vector. So we're going to have to into iter that just to keep going. And oh dear, copied. No, the issue is that filter, of course, does that. Digits, no digits on naked tuple. It's digits, it's set. And what's the complaint now? No method named filter for vector. That's because that did need to be into it, not inter. Oh, goodness me. I can't type today. Okay. So now we know that we have all of the unsolved cells in the region. And what we want to do is, if there are no unsolved cells, we can continue. So if unsolved cells.empty, continue. There's no point continuing if there's nothing to do in this region. That's fair enough. We might later add a function to regions so that there's like 2 cells and then 2 unsolved cells and things like that, but this is good enough for now. So we know that there's at least 1 unsolved cell, and in fact if there was only 1 unsolved cell in this region and it were possible to solve it at all, then it would be a naked single. So we're not interested. So in practice, rather than is empty, what we're interested in is if the length is less than 2. Is that fair? Actually, no. We want if the length is less than 3, because the smallest tuple we're going to care about is a pair, and there's no point caring about the pair unless there's another cell that would enable us to eliminate those values from it. So if we haven't got at least 3 unsolved cells, we're going to continue. The next thing that we want to do is we want to say, in the unsolved cells, how many possibilities are there? Because if there are more possibilities than there are unsolved cells, that means that this region is potentially smaller than our symbol set, and we can't do this work. But we might be able to if the region is smaller than our symbol set and we've already eliminated enough from the region. So if you imagine, for example, if this was, let's say, a 6-cell killer cage, and we'd managed to fill 2 of the cells already, so there's only 4 cells left, and those 4 cells, there are only 4 possibilities for digits that can go in it, at that point we can start to do some tuple elimination. Okay. In fact, naked tuples, we can do the elimination anyway because they're naked. Hidden tuples, we'd have to think harder about this. So shelve everything I just said for when we start thinking about hidden tuples. For now, we're only doing nakeds. So next step is we want to look at tuples from 2 to 1 fewer than the number of unsolved cells. So let tuple, for t size in 2 to unsolved cells.len. So that's going to, if unsolved cells is length 3, that's only going to be 2. If it's 5, then it's going to be 2, then 3, then 4. And what we want to do now is we want to get all the combinations of unsolved cells that exist at that tuple size. So for cells in unsolved cells, iter copied combinations of size t size. Right. So at this point, cells is a vector of cell indices, and we're interested in that set of cells. If we add all of the unsolved digits, unsolved symbols together, do we get a symbol set which is populated by exactly that number of values? If so, it is a naked tuple of that size, whether it's a naked pair, a naked triple, a naked quadruple, whatever. So what we want to go is we're going to go, let's just think about how we're going to do this. We're going to end up with cells iter copied map given the cell state.choices for the cell for self.set. So now we have an iterator of choices, and what we want to do is we want to fold them. Fold, and we can't do a fold one, so we're just going to fold. The initial value that we're going to do here is going to be an empty symbol set for, an empty symbol choice for that set. So we're going to have to work out how to get that. Let's call that state.empty choices. Actually, why can't we fold one it? That's a really good question. So I'm just going to go let foo equals that. Why can't I fold one? And expecting one argument. I'm going to do that. And are you going to tell me why you can't fold one? Closure expected to take 2 arguments, takes 1. So it's taking accumulator and value. Use of deprecated meta fold 1, use reduce. Is reduce what I wanted? So reduce takes F and gives you back an option, blah. Okay, so that's the way that they're handling it, which means I don't need an empty cell choice. Excellent. So we're going to map it. We're then going to reduce it with a function that takes an accumulator and a new set. Oh, sorry, a new choice. And returns accumulator or choice. And what it's going to complain about is that there's no implementation for bin or on symbol choice. So we're going to go and we're going to implement those. Right, puzzle, fn symbol, sorry, impl symbol choice. Right, so this is symbol choice, and down here we're going to impl bit or for symbol choice, and the output is going to be a symbol choice. Goodness me, I can type. And the way that this is going to work is we're going to assert equal self dot set and right hand side dot set. Then we're going to go bit, what choice is self dot choice bit or right hand side dot choice, which again currently isn't implemented. And then we're going to give self dot set choice. And the complaint it's going to give us is, of course, that there's no bit or for raw symbol choice. So let's go and implement that. Import raw symbol set. Nope. Raw symbol choice. Right. Bit or for raw symbol choice. Output is going to be self. And what we're going to do here is we're going to all things together, and then we're going to check, because if there's still only one value, actually, if we're ORing these things together, the result is going to be not solved, because we're never going to be ORing together two solved things of the same symbol. So it's going to be self of self.0 and value mask. In fact, is there a simple method for that? Is it just dot value? I've got an internal one for that. Any solved single value can be set options there. Let's go with that, or right hand side dot 0 and value mask. Okay. I mean, these are a bit grungy. We're going to come back to those later, but we can come back to here and we've got an option symbol choice. We are pretty convinced, I think, that this is going to have to succeed, so we can expect unable to reduce symbol choice set. Right. So I said the next thing that we need to check is whether or not we have exactly this many possibilities in this set of cells. So if foo dot, I mean, I could do options dot count, and we'll do that for now. Although in practice, I would like that to be quicker, but it'll do for now. If foo dot options dot count does not equal t size, continue. So it's not a naked pair, naked, triple, naked, quadruple, whatever. And I'm going to call this or found tuple. Okay. So at this point, we have t-size cells in cells whose values in total are what we have found in the found tuple. We can now try to eliminate any of those found in any of the other cells in the region. So unsolved cells. Okay, so what we can do now is we can go for other cell in unsolved cells, iter copied filter cell not cells dot contains cell. So these are all the other cells in the region except for the ones in the tuple that we are considering. And I think the quickest way to find out if there's an elimination to be done is to AND together that cell's options with the found tuple. So let to eliminate equal actually, no, we don't even need to be that clever. Let's just go for elim in found tuple options. State dot eliminate other cell elim if that made a change, changed is true. Mute. And this is going to be return logical step acted format found a blah tuple did some work. For now, that will do, and that's just going to be t, and that's going to be a t-size tuple. That's if changed. Right. So if we just cargo run at this point, we did more work at this point. We found a two tuple, we found a 2 tuple, we found a 4 tuple, 2 and a 3. So we've done much more work. Now, obviously, we need to report that better. And so what I was thinking was it would be good to have like an accumulator for logical step acted, where we could just accumulate what we had done and then turn that into a logical step. So let's think about that for a moment. I'm going to commit that first of all. So we're going to go git commit -a -m rules reworked naked tuple technique. Just because I don't want to end up with multiple things stuck in our to-do pile. So that's good enough for now for that. Let's start work on something that's going to allow us to report back better. So logical step, I think, does that come from constraint? So it came from constraint on the basis that, you know, that's where we were. So what I want to do is I want to derive default for logical step, and we're going to make no action be the default for logical step. And then what we're going to do is we're going to impl logical step. And what I want to do is I want to add a function to this which can add content to the logical step, and thus we can end up with some, you know, standardized things. Like if I wanted to say that this was a set of cells that I did something to, or this was an action I performed on that set of cells, we can just accumulate that into the string that we are building, and life will be good. So I'm going to go pub fn action. That's not going to take anything. It's going to take a description, which is an impl into string, and it's going to give back a self, and it's going to give back self acted that. So what that's basically done is just got us the starting point. Then what I want to do is I want to say if there is a set of cells, I want to be able to format that set of cells. And the way that we're going to achieve that is we're going to have push cells, which takes a borrow mute self, and some cells, which is going to be an impl into iterator item equals cell index. And it's not going to return anything because we're pushing that set of cells. And so this is all that we need to do. The first thing that we need to do is we need to assert that self matches acted, self-acted. In fact, the way that we can do that is we can go let body equal, sorry, self-acted body equal self, else panic attempted to push cells to a non-action logical step. And now what we want to do is we're going to take the set of cells and we're going to push them in. So the first thing we're going to do is we're going to push a space. Then we're going to go divider is empty. And we're going to go for cell in cells. Dot into, for cell in cells. Body push str divider. And then body push str format. Boop. Now, to format a cell, we need to be able to get it. So perhaps instead of taking a cell index, we could take a borrow cell info. And then I can format that. And then I can say divider is comma space. Now this is going to say there is anonymous lifetimes are unstable, expected and named lifetime parameter. Can I just tick underscore it? No, we're going to have to do that. It's irrelevant because we don't need it, but they're unstable at the moment, so we're going to do that. Let's begin the work of setting this up. So I'm going to say let mute acted is logical step acted, sorry, action, and we need to tell it. So this is going to be a format hidden t-size tuple. That's naked t-size tuple. T-size tuple in region. Do we want to format with brackets rather than? Let's have a quick look at what this says. So it says colon, blah, semicolon. So we're going to put a colon and we're going to stop. So this is going to complain that region doesn't exist. So we're going to go let region equals state.region region. And then we've got our acted and life is good. Right. If we do an elimination, then we're going to have to do some other stuff. So what we probably wanted is we want to say that we're going to push some extra text in, which is going to be, removed. And then we've got a symbol set, and then from, and then another cell group. So let's put the cell group in first. So this is going to be acted.push cells, and it's going to be cells.iter.copied.map. Given the cell, we want state.cellinfo cell. So that's push the cells in, and then we want to go acted.push str. And what we're going to push is, and we're just going to do it close to this. So we're going to go semicolon removed. And then what we want to do is we want to push, actually I'm going to put the space there, because that way I can get rid of that space that's unnecessary. And we're now going to have a push str. So pub fn push str. Mute self s : impl. Let's just do that. We're going to again get hold of that, and we're going to go body.push str s. So we've pushed the removed, and then we want to go acted.push symbols, and this time we're eliminating the symbol set that we found. So our symbol set is found tuple dot options map sim state dot symbol sim. And this is going to complain that push symbols doesn't exist. So let's repeat again. And what it's complaining about is that there is no push symbols. So let's ask it to implement that and see what happens. Generate push symbols, and let's watch what's happening. So it's saying that there's a map that produces a borrow symbol. So that's going to be an impl into iterator item equals borrow tick a symbol comma, and that's going to need a tick a, and that's then it doesn't need a goes to blah. So we're getting there. Once again, let's get our text and let's go for sim in symbols, and let's call that symbols. Body.push str format sim what's it complaining about? That needs to be mute. And then we need a divider thing again. I mean, that whole loop we could probably end up factoring out, but let's not worry about that yet. Let's just get everything that we want, which is that. So removed blah, push str from. And now all we need is whichever cells we actually changed, we need to note. So we're going to go let changed equals empty vector, which means we don't need a boolean for changed. And instead of changed equals true, we're going to go changed push other cell, because we did an elimination and it's not going to be a vec, it's going to be a hash set. Oopsie, missed the semicolon. And it's not push, therefore it's insert. And then it's not if changed, it's if changed dot, if not changed dot is empty. Acted dot push cells changed, return acted. So type mismatch, resolving hash set cell index into iterator as blah to borrow cell info. So it's change dot into iter map given a cell state dot cell info for the cell. And then it's complaining changed isn't mutable. And now if we cargo run, then what we actually get is we get a naked 2 tuple in row 4, column 3, and row 6, column 3. So we're in column 3. Let's pop that space in there so that we get this to look nicer. Removed 4 and 2 from row 7, column 3, row 3, column 3, row 8, column 3, and row 5, column 3. I mean, it'd be nice if they were sorted, but I'm not that bothered. So what it's saying is there's a naked pair in column 3, rows 4 and 6. Let's have a look. Column 3, rows 4 and 6 is indeed a naked pair. Naked pair in row 3, row 3 and row 5, column 3. That's those two. So it hadn't reached that one yet. But there's the one that it did see. You know, that was this one. And we've got a 4 tuple in column 8. We've got a 2 tuple in box 5. And then we've got this naked 3 tuple in row 5. 1, 2, 3. Removed 9, 6, and 5 from those. So our naked tuples are starting to behave. And then it got stuck. I'm tempted to update the board printer to be able to print out choices. Because despite all of those eliminations, it hasn't achieved anything else. So we had a hidden pair in column 8, row 7 and 8, removing all candidates other than 1 and 7 from row 7, column 8, and row 8, column 8. So that's that hidden pair, which is that pair, which isn't going to do anything, but we've not described finding a hidden pair yet. So we'll have to think about hidden pairs. Next, yeah, okay, let's do that. So all we've done here is we've basically made it easier to report our logical steps. So logical step, better reporting of naked tuples. Right. Okay. We might eventually want like a limit on how we report these things, but it'll do for now. Let's think about our hidden tuples. So at the moment, it's supposed to be able to see a hidden tuple, and we're failing to find it. You know, we're supposed to find this hidden pair, and we're failing to. So I want to know why. Because if we run this, we've got naked single, we've got a bunch of hidden singles, a naked single, a bunch of hidden singles. Then we've got these tuples, but we're not seeing a hidden tuple or a hidden pair. And we should be seeing a hidden pair here and here. So what I want to do at this point is pop into main, because we've got our board at this point, and I kind of just want to know what's in these two cells that we didn't spot, that there's 1 and 7 in these two cells. I mean, if I reset and run the sequence, you know, the naked pair in column 3, rows 4 and 6, boop and boop, remove 2 and 4 from all of those places. The naked pair there and there, remove 5 and 9 from there. And the next step, I believe, is spotting the 1-7 hidden pair in that box. Yes. So I want to print out box 9 and find out what we're actually dealing with, because we should have 9, 8, 5, and then a bunch of question marks. We do. We have the 9, the 8, the 5, and everything else is question marks. But we ought to be able to see that that's a 1-7. So I want that set of cells. How am I going to find that set of cells? I am going to just do it in print board. So I'm going to, when we get to here, I'm going to go for row in 7 to 9, for col in 7 to 9, println row column is, and that's going to be board dot choices self dot row cols row col get expected cell index found option borrow cell index get unwrap or copied unwrap and that gives us an iterator over raw symbol choice which doesn't implement display. Right, it's going to be print for symbol in what's it complaining about? Expected cell index got option borrow cell index. There we go. Right, so for symbol, which is raw symbol choice in, we just need to get that. So dot. Hang on. So board dot choices gives us raw symbol choices. We just want the first one of those. We want it, and we want the options out of it. I mean, this is hideous, but you know, this is life. And we're just gonna print symbol +1 because at the moment, at least, we're good. Right, so 9, 1 and 7, 6, 3 and 2, 6, 3 and 2, 6, 3 and 2, 6, 3 and 2, 7 and 1, 7 and 1, 5, 8, 6, 4, 3, 2 twice, 5, 8, 6, 4, 3, 2 twice. Some other work that we have done, which was probably that quadruple, made that naked. So there is an argument that says maybe, you know, naked pair, naked triple, those are acceptable. When you get to naked quadruple, that's probably a bit clever. But I'm okay. I'm okay with that. We're going to continue for now. So that was our hidden pair. And then we step again. We do that naked triple. We step again. We have a pointing pair. And that pointing pair is important. So the pointing pair in box 5. This is this box. Row 5, column 4. And row 5, column 6. Removed 3 from here. So this is saying the only place in this box for 3s are there and there, and they happen to be in the same region, which is here, and therefore we can eliminate that from there. So pointing sets are different again, and we can do pointing in probably digit at a time is reasonable and is okay to be dealing with. So let's do that. So I'm satisfied that the reason that we didn't find a hidden pair is because our hidden tuples got us up to, our naked tuples got us up to a naked quadruple. Perhaps I could limit that for a moment. So I could do unsolved cells.len.max with it and 3. No. I just want to say 3 is the maximum that it can go to. So I want the minimum, 3.min, that. Now if we cargo run it, we get our hidden pair rather than our naked quadruple. And the outputs are basically exactly the same. Am I... Tell you what, let's go and let's add a max n here. So it takes a set, it takes a max n, puts max n in there. We're going to read max n out here. It's not going to be 3 dot that, it's going to be self.maxn.min, like that. And then here we're going to say that 3, and then we're going to say digits dot what is it, self dot size -1. Ooh, 2 to 3 will only have done pairs. Yeah, so that only needs to do pairs, not 3 tuples. So realistically, that's self.maxn plus 1. Yep. And then here, oopsie, here, maxn is size -1. So run again, we go 2 tuple, 2 tuple, 2 tuple, 3 tuple, and then the hidden pair, and then we're okay. Good. I think that's fair. I think it's fair to say that a hidden tuple, a hidden pair, is fine. When we end up needing to implement hidden tuples for tuples bigger than 2, we'll come back and revisit hidden tuple, but for now that's acceptable. So let's just very quickly come and bodge this in. And what happened? Did I not save puzzle having deleted? I haven't deleted the lines yet. Right, so now we've just got a maximum size, so git commit. Well, this is just naked tuple, add max n. Right, pointing. So we need a new technique for pointing. I'm going to call it pointing digit because while, yes, theoretically we're talking about pointing pairs, in practice it's any set of digits which happen to be all in some other region. Okay. Pointing digits. Pub struct pointing digit is going to take a symbol set and and that's it, because yep, so set is going to be symbol set ID new self set. So that's created the technique. Let's make sure that we add it here. So larger tuples I'm going to consider after pointing. So we're going to add a technique, which is going to be a pointing digit. I really should call it pointing symbol. So let's do that. The reason I should call it pointing symbol is because that technique might be useful for things other than digits later. And now we need to import technique for pointing symbol. And this is where we get some interesting ways to handle things. So for region in state.regions. So within this region, for each symbol, we want to find the set of cells that could be that symbol. And I mean, realistically, if it's only one, then the inferences will have dealt with everything. So let's say for symbol in state.symbols self.set. I mean, we could have captured those symbol IDs into a vector to begin with. Is that worth doing? No, this is good enough for now. Because that doesn't have a captured lifetime, so we're all good. Okay. What I want to do is say, for that symbol, which cells can be that symbol, and then we want to intersect the set of regions that those cells can be in. So we're actually looking for regions here. So we're going to go let mute regions equals state dot region dot two cells dot into iter dot map. Given the cell, we want to filter first. So we're going to filter given the cell state dot choices for that cell for self dot set contains symbol and we'll see where we get to. So we're going to want here to do logical step no action, because that will shut that up. And it's going to say pointing symbol doesn't implement debug, so let's add that. And now we can actually see the real problem, which is there is no contains for symbol choice. So we're going to need to add that. So symbol choice pub fn contains self symbol ID goes to bool self.choice.contains symbol, and that's going to complain that that doesn't exist. So now we're in raw symbol choice, and that's called can be. Did we have can be exposed here? We did not. So that's called can be. And that's going to be... Is it taking a symbol ID? It is. And a symbol ID is a usize, which encodes the set and the symbol. So it's going to be symbol dot symbol index. Now, I mean, in theory, we should be asserting that this set is the correct set. So we can go assert equal self dot set dot 0 comma symbol dot set index. And then that doesn't exist, but we can implement that. Symbol index set index. There we go. And we're going to call that can be as well, because we may as well keep things roughly the same shape. So at the moment, what we have is the cell indices where the cell can be the symbol that we're interested in. We then want to map that cell index into the set of regions that that cell is in. So dot map, given the cell, we want state dot regions for cell. Now that is obviously going to go there. There is no method regions for cell, so we're going to implement that next. Impl solve state. Here we go. Right. So we want a function that tells us the regions for a cell, which is going to take a self, and it's going to take a cell, which is a cell index, and it's going to give back an impl iterator. Item is region ID. Okay, so what we want to know basically is the set of regions that contain this cell. So it's going to be self dot puzzle dot regions. What? Self dot regions dot map, given the region self dot region R dot two cells filter dot contains cell. And now we've got a hidden type with a lifetime that we can't work with. Yes, captures lifetime does not appear in bounds, blah, 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 blah. Let v equal that. Collect that as a vector. And we can just return v. V dot into iter. Yeah, I mean, that's not ideal. We're creating vectors, converting them into iterators. We're about to then convert that into a hash set, but it's good enough for now. So we've now got item into iterator blah, so we're going to collect that into a hash set. So now we have an impl iterator item equals hash set, and then we're going to reduce that by having an accumulator and a new set of regions, and we're going to do accumulator dot intersection borrow regions. And now at that point that has to be region ID, because otherwise It doesn't work. And now what's it going to complain about? Region ID EQ is not implemented. So now we get to go and add all of those bits and bobs that we did before. Here we are. That needs partial EQ, EQ, and hash. Mismatch types, expected hash set, region ID, found hash set intersection. Oh, yes. Collect. Value of type region ID cannot be built from iterator over type borrow region ID. Oh, for pity's sake. Right, and that's given us an option. We can be pretty confident that there's at least one region because it'll be the region that we're currently dealing with. So we can expect that where something went wrong collecting regions. Now it's mutable because now we want to do regions dot remove borrow region. If not regions dot is empty, then we found another region which symbol X points at, and we're just going to go here. We're going to go if state dot cell dot choices. No, I'm being stupid. It's fine. Right. So we found another region which symbol X points at. So we want to eliminate symbol ID, symbol from all other cells in that region. Or in that region. And the way we're going to get that is we're going to go if let some region, some other region equals regions dot pop. Can I do that? No method named pop. Fine. Regions dot into iter next. There we go. Oof. Right. We don't want any of the cells that are in this region to have those things removed, though. So, we're going to go let our cells equals state.region dot to cells dot into iter collect as a hash set. Again, super dodgy, but good enough. So we're going to go let mute acted. Acted equals logical step action. Pointing cells seriously tempted to break this iterate. Yeah, let's break that iterator up. I'm not happy. So 2 cells into iter, filter that, collect as a hash set. So this is not mute regions. This is in fact cells for symbol. Now we can do let mute region equals cells for symbol iter copied. Right. So this time cells for symbol are the cells that have that symbol in this region. So we found some other region. We've got an acted thing. So we're going to go pointing cells. Acted push cells of what are we going for? We're going for cells for symbol iter map given cell state.cell info of that thing. So we're now saying pointing cells blah. Now it was pointing pair in region. So pointing cells in region colon. Region is state region. We then push the cells. So pointing cells in box blah than that. Removed symbol from other cells. So acted push str. Removed push symbols. Some state dot symbol because there's only the one symbol. So removed blah acted dot push str from, and now we can go let mute what did we call it in tuples? We called it changed, so we can call it changed here as well. Hash set new for cell in state dot region other region to cells. If not cells for symbol contains cell, if state dot eliminate from cell symbol dot changed insert cell, if not changed is empty, acted push cells changed dot into iter map given a cell state dot cell info cell, return acted. And that can be collapsed. And there's a missing semicolon there. Region is unused because that needs to be a format. There we go. Let's see what happens. I mean, at worst, it doesn't work at all. And at best, it solves the puzzle. Pointing cells row 4. Let's pop the space there. So pointing cells in row 4 column 8 and row 4 column 9 removed 3 from row 5 column 7. It's interesting that that's the pointing it chose to do. Row 4 column 8, row 4 column 9. Row 4 column 8, row 4 column 9, those threes, which are the only threes in that row, pointed at that. And that's fair. They did. It's not the route I would have taken. I would have taken those three. See that? But it's good enough. Those threes saw that, so we got through it. Hidden singles, and we're done. Woo! I mean, that's good. So let's add everything and let's commit. Add pointing symbol. Now, when it comes to that puzzle, if we get rid of row 2, column 5 equals 9, which we can do by deleting that given digit, when I run it through the Sudoku Maker Solver, it says that it needs, where is it now? Here we are, a finned X-wing on 9s. So my guess is that with that commented out, that should fail to solve. And it has. And that's fair enough. So it had some pointing cells. It did that naked 3 tuple. It did a naked 2 tuple. That's all fair enough. And then it gets stuck because it doesn't know how to do a finned X-wing. And I'm okay with that for now. What I'd like to do is I'd like to improve the hiddens. So let me pop that 9 back and go again. Because at the moment, yeah, it's a hidden pair. And that's all we've implemented is hidden pair. But I'd like to support hidden triples and so on. So what I want to do is rewrite the hidden tuple to be like naked tuple. And I appreciate this is going to be fairly pointless, but I'm only intending to stream for about another hour at maximum, and I'm not convinced I can explain a finned X-wing in that time, let alone actually write an implementation for a solver for it. So what I will do is we'll do this, we'll maybe go and do some other cleanup, and then next time we'll look at finned X-wing. Right, so hidden tuple, I'm also going to give a max n to, because I think that's fair. And let's just very quickly come in here and go hidden tuples, max n is going to be 3. I think that's fair again. Hidden pairs and hidden triples, sure. Hidden tuples that are bigger than that, not until later. And that's fair. Right. So let's just remind ourselves how we did hidden tuples, and then we're going to delete all of that code and effectively take our naked tuples, but go ahead and try to simplify it. So hidden tuple can only see pairs with this horrid code. We should improve it. So what we did was we said for our we said give us all of our symbols. We then said for the region, I want to map from symbol ID to a set of cells that contain that symbol. And then we faffed about with, you know, if this pair of symbols is in the same pair of cells, then we can say it's a hidden pair and we can act. That's all hideous. Let's effectively delete from there. And go again. So, what we're going to do again is we're going to look at combinations of symbols. So we're going to go for symbols in symbols.into iter.combinations t size. And we're going to go for t size in We want let's actually come up here and let's go again with our unsolved cells, and then let's do our T size within that and build from there, because I think this is a fair starting point. So what we've got here again is we want the unsolved cells in the region. If there are less than 3 of those, we're not interested. Because obviously, if there's 1 unsolved cell, it's probably naked. If there's 2 unsolved cells, it'll be a pair. If there's 3 unsolved cells, there could be a hidden pair. And that's what we're looking for. So we're going to go to 2 to max n plus 1 on min unsolved cells. So our tuple size is selected. We then want to select each. How do I want to do this? What we're interested in is finding the set of symbols. Okay, what we're interested in is going, okay, give us the cells for this tuple size. So for cells in, and how did we do this before? We did, yeah, unsolved cells, iter, copied, combinations. So it's unsolved cells, iter, copied, combinations, T size. So we have a set of cells, and those cells will be some number of cells within the region, whatever region it is. And what we're interested in doing is we're interested in finding all of the digits that can be in any of those cells. And then what we're going to do is we're going to look for whether or not those digits are found in cells that aren't in this combination that we've looked at. Woo! Yeah. So we're going to go cells is hash set from cells. Can I do that? Cells into iter. I can't do a hash set from. So it's just going to be cells.into iter collect hash set. Just because I think it will be better if we have a set of cells, because later we're going to iterate again over unsolved cells, and we want to do the unsolved cells that aren't in that. Can I collect unsolved cells into a hash set? Yes, because we can still get a len of a hash set. So that lets me do the difference, which will enable me to just look at the cells that I should be looking at. Okay, so what we now want is we want all of the symbols that can be in any of the cells that we have found in this tuple. So if you imagine here, where is it? Yeah, so here we said that we'd found this tuple where we ORed our choices in. We're going to do the same thing, except we're going to AND our choices in. So let's copy that and bring it down here. And rather than ORing them, we're going to AND them. So now I'm going to have to do bit AND. So let's go and do that. I'm just going to make that self because it's a little neater. So we're going to import bit AND for symbol choice. The output is going to be self, and we're going to get basically exactly the same body, accepting that that is going to be an AND. And lo and behold, we now need to drop into here. And just like we've got bit or, we're going to have to do the same again. We're going to have to go import bit and for raw symbol choice. Self. And this time it's going to be self, self.0 and right-hand side .0. And this time it doesn't matter, because if both of them are solved to the same digit, I'm going to do an and self value mask, because if that unsolves it, then so be it. That doesn't matter for the sort of work that we're doing here. Okay, so we can come back out of there. We can come back to our tuple. So in this context, our found tuple is the set of symbols which exist in all of the cells that we have looked for. If that is nothing, then it's not a hidden tuple. In fact, if the number of things that are equal, that are present in all the cells, does not equal the size of the cells, then we have not found a hidden tuple. So if found tuple dot options dot count does not equal cells dot len, continue. Okay, we have found tuple present in all cells. We should eliminate anything not in that tuple from those cells. Whew. Right, here we go. Thought. By OR them as well as AND them, if the two tuples are equal, then we've actually ended up with a naked tuple that we've already dealt with, so we don't need to think about it. That might be more efficient, but realistically, efficiency is not what we're after, so if later we find we're wasting time here, we'll think about that. Right, okay, so we have found a tuple, so we need to act. Let mute acted equals logical step action hidden blah tuple in region colon. Region is state.region. Push cells. Cells iter copied. Oh, just map state cell info cell. So we've said hidden tuple in region blah cells. How does this report the hidden pair in region cells? Removed all candidates other than blah from cells. I'm just going to say remove all candidates other than blah. Acted.push str removed all candidates other than. And now we want to print the symbols. So that's going to be acted push symbols found tuple options map given the symbol state dot symbol. And now all we need to know is, did we actually do it, or was it hidden? Sorry, was it not hidden? So that's going to be let mute changed equals false for cell in cells. Is there a get mute? Is there a choice mute? Did I write that? Regions, cell symbols, choice, cell info, choices. That gives a symbol choice object back. So no, we then had eliminate. I'm going to have a restrict. Pub fn restrict. Yeah. Which takes a mute self, a cell, and a symbols, which is going to be a symbol choice. And it's going to return an effect. And this is going to be self.puzzle.restrict mute self.board cell and symbols. And now let's write that. Restrict self board mute board cell. We've got a symbol choice. Okay. Right, so it's going to be choice is board.choice mute cell and symbol. So that gives us our raw symbol choice. We're still going to have, in fact, all of this stuff. And the difference is instead of choice unset symbol number, it's going to be choice restrict symbols. No, we can do better than that. We can choice and equals symbols dot choice. And that's going to complain that and equals doesn't exist, and that's no good. And that's going to be symbols dot set choice mute takes a symbol ID. Choice set gives a raw symbol choice. So can I do a choice mute by set, which instead of taking a symbol ID, takes a set bugger. That's not what I wanted. I wanted to just go and find the code I've had that's broken. So it's going to be choice mute by set. And now our error is that expected to use size found a symbol set ID. That's good, because I'd rather do that. So that's going to be set.0. And now it's just the binary and equals that isn't supported. So let's go and add that. Impl bit and assign for raw symbol choice. And that is just going to be self.0 and equals right hand side .0. And self value mask. Now we can come back here and we can go, okay, so and equals cannot be applied to type borrow mute sim. So it's star choice and equals that. If star choice is that, we propagate it and we changed. Otherwise, yeah. Back to here. Woof. So, for every cell, if state dot restrict cell to the found tuple dot changed, we can just go changed or equals that. If changed, a return acted. So we're not allowed to pass found tuple because it got moved somewhere else. Where did it get moved? It has type symbol choice, which does not implement copy. Really? Symbol choice should implement copy. There's no reason for it not to. There's no borrows or anything weird in there. That now works. That's missing a format. T size. Yeah, so we've got a hidden 2 tuple, removed all candidates other than 9 and 5 in row 3. Interesting. It then did a whole bunch of stuff and then it panicked. Yeah. So something went wrong in pointing, which means that we cocked up our hidden tuple code somehow. So let's think about that, shall we? What did we cock up? Let's clean out. And what happened was we ended up hidden 2 tuple in row 3. Row 3, column 2, row 3, column 3. 5 and 9. So row 3, columns 2 and 3, 5 and 9. So let's step until we see that. So at the moment, 5 and 9 could be there, 5 could be there, 9 could be there. We're still in the situation that 9 could be there, so that can't be a hidden 5-9 pair yet. That's now 5-9. Oh, so that's now saying that is a hidden pair. And that's not true. Yeah. Bug. What did I forget to do? I forgot to do the check. So we got our unsolved cells. What I forgot to do was to say that having found the tuple, we need to double check that it's not present in any of the other cells. Yes. So we have found tuple present in cells. We now check that it's not, that none of it is present in other unsolved cells. So for cell in unsolved cells difference, so this is values that are in self but not in other cells, copied. If state choices cell self.set and found tuple dot options dot next dot is sum. Blech. Right, so what it's whinging about is mismatched closing delimiter somewhere. State dot, yeah, we're missing an open paren there. Okay. So, I mean, again, efficiency, screw that. We'll worry about improving efficiency later. So what we've said now is we've said for every cell in unsolved cells, which is not in cells, i.e. for everything that's not the tuple we're considering, if the choices available in that cell masked with the tuple that we found has anything in it, then we can't do this because some of that tuple is found outside of the cells. So some of our found tuple is present outside of cells. Continue. What happened now? So that still says it happened. Hidden 2 tuple in row 3. Removed all candidates other than 5 and 9. This is the first time we see a hidden tuple. So perhaps we can do something to step through and find out what on earth is going on. I've never used the debugger in this before. Can I successfully? Oh, I better not yet. Oh no. The moment it thinks we've found one, we can think about it. Can we? Yeah, because the moment it thinks we've found one. Well, let's just go print learn. Whoa, found something. Let's see whether that fires. Doesn't fire until the one that we think is broken. Good. If I just do that, and then I do that. Yeah, whatever. Yes, please. Code LLDB launch. Program is Kaji. I don't know. I mean, we want it to debug the executable Kaji bin. Go. Debug adapt terminated abnormally. Okay, I don't know how to do this in VS Code, so I'm not going to worry about it for now. I'll try to set up debugging for next time, because I think it would be useful for us to experiment with that. But for now, we can just do it with printing stuff out. So at this point, what we think has happened is that we have found a 5-9 pair there. But I don't believe that for a second. So what I want to do is I now want to print out everything in here. Right. So println cell blah, which is going to be state.cellinfo cell has choices blah, which is going to be state.choices cell self.set. Okay. So we found a 2 tuple, 9 and 5. So 9 is going to be 2 to the 8, which is 2, 5, 6. So row 3 has that. So that's what we would expect that to fail because 9 and 5 are present. So let's do a little bit more printing. Let's go print learn found tuple like that. So the found tuple has 272, which makes sense. That's 256 plus some 258, which is 2 and 9, 3 and 9, 2 and 9, 1 and 9. I don't know. It's got something and 9 present. That continue is continuing this loop, where what we want it to do is to continue this loop. So this is going to be cell tuple. And we want to continue cell tuple. That's better. Let's get rid of all of our debugging and then check that things make sense. So this time we said some naked tuples, some pointing cells, some nakeds, and we finished. So we didn't get our hidden pair at all. I mean, that's frustrating that we didn't find our hidden pair at all, but we did solve it. And I mean, 376842. Let's just double check if we run all the way to the end. 376842. So we definitely solved it correctly. We're just doing something different. Do we think we should restrict to pairs? Yeah. Let's see what happens if here we go. You're going to do only pairs, and then later you can go up. So if we do that, then we get 2 tuple, 2 tuple, 2 tuple, pointing cells, single, 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 single. See, nothing about that is a hidden pair. It's never said there's a hidden tuple. And yet it solved it. Weird. I mean, that is super weird. But, I mean, if it never needed it, then it never needed it. Okay. I'm going to set that back to 3 because I think 3 is possibly more polite, as it were. And at this point, we're going to assume hidden tuples are working. Let's get rid of that directory because it was a failed attempt at doing debug. I will look into adding support for that. If I do, then I'll keep it uncommitted so that next time we can look at the debug support. So what's going on in Kaji? We added restrict and some more stuff. Symbol choices. And then here we rewrote hidden tuple. That's good enough for me. Actually, there's a thought. If we come back to main and we go back to needing the finned X-wing and we cargo run, then do we get any hidden tuples at this point? Hidden single, pointing cells, naked single, naked 3 tuple, naked 2 tuple, hidden single, naked 2 tuple. Nope. So still no hidden tuples in there. Interesting. Okay. We're going to have to find a puzzle that requires hidden tuples to know for sure that we've implemented them correctly. But we can worry about that next time. Do we want to see if we can sort out the debugger now? Yeah, let's see if we can sort out the debugger now. So, I mean, LLDB obviously isn't available, which might be part of the problem. Rust LLDB. LLDB not found, please install it. Okay. Step 1, let's add LLDB to our dev shell. So, I mean, that starts at least. That's good. So if we do rust LLDB target debug kajibin, b main run, then we're not exactly getting debug information out of this, but I don't know. Maybe that would be good enough. Let's see what happens if we now try to do a debug start. So what happened here? Let's terminate that. I don't know why that still thinks it's trying to run and debug, but hey. I tell you what, let's restart VS Code, because who knows? At this point, I'm learning along with you because I've never used the debugger in VS Code. I just think it might be a nice idea to have a go. So what we're going to do is we're going to close out all of that. We're going to come to main and we're going to set a breakpoint here. And we're going to run and debug. And this is going to be using LLDB. No launch configuration has been provided. Docker extension is becoming the container tools extension. Don't show me this again. This is all very confusing. Yes, I want you to do that. Don't show me that again. Let's think. Right, so what we want to do is we want to debug executable kajibin run. Debug adapter terminated abnormally. What does it mean by that? How to use code LLDB with Rust. That's something, someone complaining about something or other debugging Rust with VS Code. Rust compiler uses that. So run start debugging. Okay, yes. Can't do that. Yes, yes. Creates all of this. Breakpoint. Debugging actions. They say that it just works. Well, clearly it doesn't. So what we're trying to do is we're trying to launch kajibin. So we do cargo build bin kajibin, filter that, args that, coed that, type LLDB. Let's have a look. Problems. Right, I mean, that's just tidy up stuff. Debug console. Nothing. Output. Code LLDB.cargo tasks are unavailable. Don't know what that means. So that was faffing about with Docker. I don't know why I was faffing about with Docker, but hey. Let's kill VS Code and start it again, because maybe it needs a restart. I don't know. It does. It's Microsoft software. Maybe it needs a restart. Debug executable kajibin. Go. Code LLDB. Open the log. So. Could not start dynamically linked. Oh, for goodness sake. Why? Okay, I'm going to have to try to really futz about with that, so we're not going to get there yet. So instead, what we're going to do for the next little while is just try to get rid of any of these remaining cleanups that we need to do. So cell index isn't used, clean that out. We're not using symbol set digits in puzzle. Makes sense. Cell regions. Ah, we have that and we never read it. So we're going to come back to that because that's an efficiency that we can do so that we're not refiltering stuff. Let's come back here. New and push for raw symbol set are never used. Okay. They can go away then. Don't believe in keeping these things around when we really don't need them. We're not using hash map anymore. Remove all the unused imports. So the only problem that we have now is that cell regions is never read. So git commit. Chore, clean up, unused imports, etc. And now what we're going to do is we're going to use cell regions, right? So let's go to our pointing, which is where we're computing the regions for a cell. Cells for symbol. Regions. We got regions for cell. And regions for cell does this, which it really doesn't need to do. Because we have cell regions, they're in puzzle. So it's going to be self.puzzle.cell regions cell.0 Right, so what have we got? We've now got a vec of region IDs. So we just want to clone that and convert it to an iterator. And there we go. That would be much more efficient because we're not having to rework every time. And let's just cargo run to confirm that we didn't break anything. Pointing cells still work. Clean up. What was it called? Regions for cell? Yeah, regions for cell. Okay. I think that's probably enough for today. We're stopping again just a teensy bit earlier than I was intending to, but that's okay. And what I'm promising I will do is this puzzle, if we remove that 9, needs a, where is it now? Here, finned X-wing. I'm going to, so was it naked? So it goes hidden pair, hidden single, naked single. Let's step and see if we can find it. Naked pair, naked, hidden single, naked single. Naked single, no, hidden single, naked single, naked pair, hidden single, naked single, finned X-wing. Right. So finned X-wing on 9s in rows 2 and 9. Removed 9 from row 3, column 6 and row 8, column 5. So finned X-wings on 9s in rows 2 and 9. So 2 and 9. 9 can go there and there, and it can go there and there. And it's saying that it removed 9, therefore, from the 2 yellow cells that are highlighted. Okay. I can tell you why that works, but telling you how to find that, oh boy. So essentially what we're seeing is first of all that 9. So we know one of those two is 9. And we know that if that's 9, then that is 9. In which case neither of those can be 9 because they're both seen by that 9. If that's not 9 but that is 9, then that is 9, and again those two both see that 9, and that's why they're removed. Normally, a normal X-wing would be like if the 9s were there, for argument's sake, and then you go, okay, well that means that in those two columns we've seen both the 9s, therefore we can't have a 9 anywhere in that row, and we can't have a 9 anywhere else in that row because we've seen them both. But because it's finned, that's where you can see that it's columns 5 and 6. I have no idea how I'm going to implement that. I will need to ponder on that. If any of you have any ideas, please leave a comment and I will see what I can work out. Otherwise, I'll approach this the next time that we're going to try and solve puzzles. Okay, did I push everything? I did. In that case, I'm going to say good night to you all and see you next time.